solve for x in the equation. Log base 2x plus log base 2 10 minus x equals 4. So in here we are not ready to undo the logs. So you can't undo logs unless you've got either log something equals log something else or log something equals numbers with no logs. We are not ready to do that because we have log base 2 of one thing equals log base 2 of another thing. So what we're going to do is use the first law of logs to make sure we're going to write the left hand side just as a single logarithm, and then we can undo that logarithm. So log base 2 of x plus log base 2 of 10 minus x equals 4. So using the first law of logs, we can write this log base 2 of x times 10 minus x. Log base 2 of x 10 minus x equals 4. So just expand that bracket. Log base 2 of 10x minus x squared equals 4. So now we are ready to undo the log. We undo the log by raising the base to the power of both sides. So raise 2 to power of both sides. Exponentiate. So that would be 2 to the power log 2 10x minus x squared equals 2 to the power of 4. Log base 2 of 10x minus x squared means the power that you raise 2 to in order to get 10x minus x squared. So then if we raise 2 to that power that we need to raise 2 to get 10x minus x squared, we will get 10x minus x squared. So this whole term on the left hand side is 10x minus x squared. On the right hand side, well, it's 2 to the power of 4, which is 16. So now you look at it and it's looking very quadratic like. If it was me, well, it is me, I would want the x squared term to be positive. So I'm going to leave the 0 over here. I'm going to add x squared to both sides. So x squared, I'm going to leave a 0 and I'm going to subtract 10x minus 10x plus 16 equals 0. Then I'm going to look to factorize, and it looks like an 8 and a 2, if they're both negative, will achieve plus 16 when they're multiplied and minus 10 when they're added. So that looks quite good. So this would be x minus 2, x minus 8 equals 0. So that tells us that x equals 2 or x equals 8. Now when we do these things, because we ended up not actually solving the equation that we had initially, because when we did this raising 2 to the power of both sides operation, there is a danger that you can create extraneous solutions, because you're kind of going a power up, as it were. You're powering up. So what we should do, we should check both of these values in the initial one. So sometimes you'll find that they're outside of a domain. Remember, logs, if it's a positive base, for example, then you can't take the log of a negative. So if one of these made the thing that you're taking a log of negative, then that would be a big red flag. So let's just check. So substitute x equals 2 into log base 2x plus log base 2 10 minus x equals 4. So that would be log 2 plus log 2 of, well, it's 10 minus 2, which is 8, equals 4. So is that true, basically? So log 2, power you raise 2 to get 2 is 1, plus the power you raise 2 to get 8, well, that's 3. Does 1 plus 3 equal 4? Yes. So x equals 2 is fine. So if we do the same with when x equals 8, and x equals 8, I'm not going to write the whole thing, I'll just write log base 2 of 8 plus log base 2 of, well, it's 10 minus 8, which is 2. So actually it's just the same thing, but the other way around, equals 4. So it must be true. So actually, these solutions are both fine. They won't always be fine, so you should do this checking process when you end up raising a base to a power of both sides. You can create solutions that are not, remember, they're solutions to this equation here. It doesn't mean that they're both solutions to the original thing we started with. You do need to check that. But in this case, they are both absolutely fine.